back in chapter 1, we talked about setting up an equation to solve a word problem. And sometimes systems of equations can be a much easier way to approach certain types of word problems, especially problems like these ones. There's a couple in the homework, and I just kind of want to review that and say, well, how could I apply this, and how could I use systems to solve it instead? Now, you don't need systems to solve certain questions like this, but in my opinion, it's just way easier to get the setup and to get rolling. So let's review the question, and then we'll try to write equations in order to solve it. So it says, in Canada, $1 coins are called loonies because they have a picture of loon on the reverse, and $2 coins are called toonies. When Marissa returned home to San Francisco from her trip to Vancouver, she found that she had acquired 26 total coins with a total of value of 37 Canadian dollars. And then the question is, how many coins of each denomination does she have? And basically, these are the very, very standard types of questions where you can use systems. And for me, I've taught algebra a lot, so I can just kind of tell when one is. But you can often tell because you have two different types of things in the problem. You have $1 coins and you have $2 coins. And one of the things that we're told is she has a total of 26 coins. So you could say, we could call L loonies, because one of the things we don't know is how many loonies do we have and how many toonies we have. We could say that that's L and that's T. And then if I did L plus T, those should add up to 26, because that's her total number of coins. We don't really know how many of each denomination she has. So let's go ahead and write that out, because that's one equation that we know. The number of total coins she has is 26. And you can use X and Y. You can use whatever letters you want, but in a case of a real problem, we often just use whatever letters make sense, because then we know later what they represent. And then the second thing we're told is that those coins had a total value of 37 Canadian dollars. And basically, well, and these sorts of equations are very common, because I like to think of the second part as like a value. The first one is an amount. It's like, how many total coins do I have? And the second equation that I write is correspondent to their individual value. And so sort of thinking about it, I know together they have a value of $37. But what you want to make sure to do is account for how much each is worth. Because, well, if she has some number of loonies, those are each worth $1. And if she has some number of toonies, each one of those is worth $2. So if we're thinking about the value, and like also, if another strategy, if you're like unsure of how, like, this is not something that's easy to think about. And I'm trying to explain to you how I think about it and how I'm able to create these equations. But for some people, it's very hard to like think algebraically in terms of quantities and writing equations. And that's, what I'm really trying to focus on mostly. If you're in that branch where you have a lot of times you have difficulty creating equations, what I suggest is like, say, well, we don't really know the answer, but let's just hypothesize what a solution looks like. Let's say she had 10 loonies and 16 toonies. That would make 26 coins. So maybe that's my answer, right? I could hypothesize the x comma y coordinate, or L comma t in this case. But it would have to work in both situations. So the first situation is she has 26 coins, but the second thing is the other thing I gotta make sure it adds up to, that when I add up all those coins, it makes $37. And if I have 10 loonies, well, each one of those is only $1. If I have 16 toonies, well, that's really $32. Because, right, I just doubled the number, because T represents the number of coins, and if I multiply that by 2, that would give me the value. So it's kind of like I have the value of the loonies, which is just 1 times L, and the value of the toonies is 2 times T, because that's what they're worth. And notice that this solution doesn't make sense, because that would add up to $42. But what I was told is that those need to add up to $37, and that is the source of my second equation. So anyways, after all said and done, I get my system of equations, which was information that I had. But I still need to write them, and then, of course, how do I solve? I could use substitution, elimination, or even graphing. Whatever you want is totally cool. In this case, elimination should be pretty easy, because if I just say negate the second equation or the first equation, again, you could do it either way. Now they'll be ready to eliminate, and I can add them up. L minus L is 0, elimination. T minus 2t is negative 1t, and 26 minus 37 is negative 11. And if I divide by negative or just negate once again, I would get that T must be 11. And since I have 26 coins in total, of course, L would have to be then 15. And I would figure out exactly how many loonies and toonies she had. And of course, I could then, a common practice when solving a word problem is to then write out your solution, as I was saying before, which is always good to do on your homework or activities or your exam or whatever. But at the end of the day, it's totally cool because with online homework, just be plugging it in, filling in the box. And if you're wondering, should I write it as an ordered pair? Not necessarily, because we didn't really know, well, which one's X, which one's Y, right? L versus T. You could go alphabetically or whatever, but, I wouldn't necessarily use an ordered pair unless it was obvious which is which. And, of course, we could make sure it makes sense, because we can see that that's a total of 26 coins, but does it actually add up is the final question. And, since each loonie's worth $1, that would be 15 Canadian dollars. And each one of those is worth $2, that would be 22 Canadian dollars. And yeah, that makes a total amount of $37.